Hey guys, let's go over how to find a piecewise function using a graph. I mentioned that we didn't get time to do this in class, so here's going to be a small video going over these last two slides from the lecture. We're going to go through how to do this specific example, but it applies to any piecewise function that you see like this. For the time being, you're not going to be asked to find a piecewise function for anything besides lines. So as long as you remember how to find the equation of a line, you're going to be able to do this question. Okay, so the first thing that we want to remember is what actually is the equation of a line. One of the ones that you can use, and this is the most basic one, this is like the equivalent of the mitochondria is the powerhouse of the cell sort of thing. Um, it is y equals mx plus b. We've got that up here, wrote it in case you forget. But what do m and b represent? B is going to be the y coordinate of the y-intercept, so the interesting number of that point. And m represents the slope, or in other words, kind of like a measure of the steepness of the line. So for example, if your slope is 0, that would indicate that your line is completely flat. If your slope is negative, that would mean your line is pointing down. And if your slope is positive, that means your line is pointing up. Okay, so as you can see in the picture, we've kind of got two lines going on. We have this first line here that's going down, this tiny little pink one, and we have this green one that's going up here. Doesn't matter which one you start with. I'm just going to start with the pink one first of all. Um, I need to find the slope and the intercept. I need to find m and b. Well, fortunately for me, the y-intercept is pretty clear. They've given me this point here, which is 0, 0, so I know that my y-intercept is going to be 0. So in my y equals mx plus b formula, I know that b is going to be 0. And that's what's indicated over here with the arrows. So I know that my y-intercept is 0, so you can leave this as m for right now. I don't know it yet. So y equals mx plus 0. Okay, and I wrote that a negative 1 was here. So I said my slope is going to be equal to negative 1. So here's the calculation for the slope. There's a couple different ways you can do it, a couple different names for it. So slope is one name, m is another name. Sometimes you might also hear rise over run. And then finally, this is the truest like formula interpretation of the slope, and it's the difference in y values between 2 points divided by the difference in x values between 2 points. You could think of this part as your run. What's the difference in x's? Difference in y's is going to be your rise. So if you're lucky and your points happen to fall on a nice grid like they've given you here, you don't even have to do any calculations. You can just count. So I want to count what is the difference in my y values, and it looks like I start at 1 and I end up going down to 0. So I going down by 1 unit because I'm at 1 and I go to 0, so down 1, going literally counting down 1 block. And how far over did I go? I went from negative 1 to 0, so I went up by 1 unit. That's why I've written over here negative 1 for rise. Run is positive 1. Essentially, I go down 1 over 1. That means my slope ends up being negative 1 when I simplify. Alternatively, another way that you could have done this is you can just take the values for the points and do this particular calculation. So for example, I'm just going to throw this over here and write it off on the side. This is not necessary because we've already solved it, but just in case you wanted to do this, what I would say is, all right, what are my two y values? I'm going to just say my first one. It doesn't matter which one you call first and which one you call second, as long as you're consistent. So let's say my first point is this one. So my first y value is 1. Okay, what is my second y value? My second y value is 0. Replace that with a 0. Okay, now for the x values. My first x value is negative 1. And my second x value is 0. And if we go ahead and simplify this a bit more, minus 0 doesn't change anything, so this is really just a 1 on top, a negative 1 on the bottom, and hey, guess what? This still works out to be the exact same negative 1 that I decided it was over here just by counting blocks. So you're able to do this calculation without even doing any math. Or sorry, you're able to count and you're able to do the math, and it'll take you to the same result. Okay, so let's repeat the same process for the green one, because now we've basically identified the pink line or the purple line. It's going to be negative 1x plus 0. You don't have to write the 1. You don't have to write plus 0. You can just write negative x. So that's what I've listed here already. I can tell that the pink piece, I'm going to go ahead and color this in pink so we know that this is the correct, we know that this is associated with this. We'll fill in the question marks now. So let's repeat the same process for the green one. I can count blocks or I can use the formula. So I'm going to say this is going to be my first point. So from 0, 0, I want to get to 2, 3. So my rise is going to be 1, 2, 3 units. So I'm going to go ahead and draw that with a green pen. So I'm going to say my rise is 1, 2, 3 units. So rise, that's going to be 3. All right, and how far over did I go? So from the starting point, I went over 1, 2. So this is run 2. So my rise, 3, my run, 2. So this ends up being my slope. What's the y-intercept? Well, it's the place where it crosses the y-axis, and that's actually shared between the green and the purple/pink line. They both meet right there. So this is also going to be 0, 0. And there we have it. So if I want to put this together into an equation, I know that I should have m, which I just decided was 3 over 2, x plus, and then b is 0. Now there's no need for me to write plus 0. That's not adding any useful information. So I can just write 3 over 2x. And I'm going to go ahead and color code this green, so that way we know it's associated with the green line. Okay, what about these? So these are the conditions for the piecewise function. Essentially, where am I using this purple/pink line for? Where am I using the green line? For what x values? And the answer to that is look at your picture and decide what x values your line lives in. So if I look at this pink line first, the x value where it starts at negative 1. And then I continue to use the pink line until I hit 0. And then afterwards, I'm switching to the green line. So this little range of x values in between these two, this is from negative 1 to 0. I use this line only in this little span. So I'm going to say if negative 1 less than x less than 0. That would be how I phrase. I'm going to move this a little bit. So that's how I phrase what I'm trying to say. Now, because this point is actually there, I'm going to need an equal to on this left-hand side, because I'm allowed to plug in negative 1. When I plug in negative 1, I actually get out 1, so I have to include the equal to here. Now, because the green line and the pink line or purple line, whatever, because they both share the point 0, 0, you kind of have to decide which line is going to get the 0 and which one isn't. So I think in Pearson, these are already listed for you, so you don't need to write it. So it looks like they want this one to have essentially they want to include the 0 with the first line and not the second. But it's fine. That's not necessarily the only way to do it in this case. There's another way that you could do this and get the same picture with the same values. But it looks like that's what they've decided. You kind of have your own choice, though, if they don't tell you. But it would be okay. You could come up with an equal one where this is only a regular less than symbol. But like I said, because Pearson has decided we need the or equal to here, we're going to keep it. Keep the symbol. Okay, so now for the green line. Where do I use the green line? Okay, starting at the x value of 0, I'm on the green line, or rather like just after 0. But we could pretend. So I'm on this green line, and I continue being on the green line until I hit the x value of 2. Afterwards, there's no line at all, so it looks like I'm only using the values from 0 to 2. So my other condition is going to be from 0 to 2. And again, I need the underline over here because I actually can plug in the value of 2. When I plug in 2, I get 3. That point is really there, so I need the or equal to. However, I don't have it here because technically speaking, if I want to put in 0, it goes to the pink line. It doesn't matter in this instance. Like I said, if I plug in 0 into the green line, it's also going to give me out 0 because they kind of share this point. But you have to pick one. Either the 0 goes with the pink line or it goes with the green line. You technically can't have them both include 0. Let's say I did, right? Let's say I did put an equal sign there. If I plug in 0, I need to ask myself, all right, well, where does 0 belong to? And the answer is it belongs to both. So there's ambiguity, meaning I don't know which one of these lines I'm supposed to use. So that becomes a problem for piecewise functions. That's sort of why you need to decide where you're going to keep 0. And like I said, Pearson has decided that 0 belongs to the pink line and not the green one. So in the end, this is what we get for our solution. The hard part of this is just come up with the equations of the line, and then the second portion is decide what little x span or x interval this line is being used for. And then you want to write that using inequality notation. And there you have it. That's how you form the equation of a line and make a piecewise function with 2 lines.